Hi friends, this is Krish here. Good evening, good morning, or good afternoon from wherever you are. So we are doing the live sessions, live programs on for the demand forecasting using Python. We have done a couple of series earlier. I hope you have watched those series and you have got the benefits out of that. I hope you have tried those algorithms by your side, on your side, through your side. I hope you have been successful in replicating those algorithms from your side. So we are doing this series. So today we are going to see a new series or a new algorithm, and the new algorithm is there's two very important algorithms. They are called weighted moving average and exponential moving average. Weighted moving average and exponential moving average. These are two very popular algorithms which are used in forecasting. So we are going to cover these two algorithms in Python today. I hope you are able to hear me. So let me test on my system whether you are able to hear me or not. Because sometimes what happens is I do the live and the voice is not reaching to you. So that becomes very unproductive. And what happens is I do the live. I think everything's working fine. So I'll just explain a bit the concept, and then after explaining the concept, I'll move into the Python. So what is weighted moving average? Suppose we have a data. For example, I plot a graph. Suppose we have a data like this. Okay. And the data graph is being plotted like this. So this is a historical sales plot. So what I will do, I'll take a different color, and if I have to do a forecast, I can also do a forecast using a method called average. So if I take the average of this data, which is somewhere over here, this is a flat line, right? This forecast average is a flat line. So when you make a forecast with flat line, so there will be a lot of gaps between the historical sales and the forecast, right? There are a lot of gaps. So what I want is I want a forecast which is close to this, right? Which is close to this. This is a desired forecast. So to get this desired forecast means to get away from this flat line, we need to move something closer to this red line. That's our historical switch. So to achieve this kind of forecast, we may try these two kind of models. That is weighted moving average and exponential moving average. So what we do in the weighted moving averages, suppose we have a data like this 20, 18, 13, 10, 50, 2, 47. So what I can do is that I can take the average of these three values and give different weightages to these three values. For example, I say in my third period, the latest period will have the highest weightage. The latest period having the highest weightage, and the first period having the lowest weightage, and the middle period is having the medium weightage. So suppose I give the weightage to the last period as 50%, second period as 30%, and first period is 20%. So my average will be 20% of 20 plus 30% of 18 and 50% of 13. This is my forecast model, and this is called weighted moving average. Why we say moving average? Because now we for the second forecast we'll take these sum of these three values, like weightage of this, weightage of this, weightage of this. Now for third forecast we'll go to these three values. For the forecast we'll take these three values. Right. So we are our combination of three values is moving from top to bottom. That's why we say this is moving average. So this is weighted moving average. So like this, we are going to move forecast. So here we're taking the weightages. What is the weightages here? 20%, 30%, and 50%. Right? And these are data. Data is what? Or sales data. Or sales call. So this is the concept behind the weighted moving average. But what is the concept behind the exponential moving average? The exponential moving average is we in the exponential moving average, suppose we have a data like this, right? So first of all, I have to find the weightages. Suppose if I take 6 period moving average, 6 period moving average. So my weightage will be 2 by 6 plus 1 and 1 minus 2 by 6 plus 1. And my here I am taking only two weightages. So what I'm going to do, suppose if I have to do, suppose if I am taking 6 period for 1, 2, 3, 4, 5, 6. So 6 period for, so this is my 2 by 6 plus 1 into 19. And I have some forecast over here. Let's say this previous forecast is something 20 plus 1 minus 2 by 6 plus 1 into the previous forecast. The model here is that, so if I say 2 by 6 plus 1 is equal to alpha, then 1 minus 2 by 6 plus 1 is 1 minus alpha. So what is the model? Alpha into current period sales plus 1 minus alpha into previous EMA forecast. Exponential moving average forecast, previous period. This is a model formula I'm going to use for the EMA, that is exponential moving average. Right? So this is a concept. And the reason why we are using this concept because a flat line average is not a right forecast. So we need a forecast which maps with the pattern. So that's why we are going for weighted moving average or exponential moving average. So how to execute this? How to execute this in Python? Let's see. If you have any questions, you can email me or WhatsApp me, or you can just message me on the social media page. I'll be able to reply you later once I finish this live session. So my email ID is Krish Naidu at the rate of mathanel.com. And WhatsApp ID, my WhatsApp number is +98977924637. This is my WhatsApp number. So please connect with me over here and I will be able to help you out. Or you can just post a message on the social media. Okay. And I think I'd like to take an opportunity to share that we are also launching training program from 30th June. We are launching a training program from 30th June. If you want to join this training program, so please connect me on this particular contact details, and I will be able to help you to share the details of the course. So let's move to the so this is Python, and Python is a Jupyter notebook. So first of all, I'll just import some of the packages and libraries. So I'll import pandas SPD. I'll import numpy as np. I'll import matplot lib.pyplot as plt. I'll import first of all pip install skykit learn. I'll in, from skyline dot metrics import mean absolute percentage error. So the metrics I'm importing from scikit-learn. So let me run this. I'm clicking on Shift and Enter to run this codes. So now this is right done. Now what I will do is I'll import the data. So the data I will to import the data Excel file. I have to write the code that is pd dot read underscore Excel r apostrophe. So I have to copy the file path now. So I'll go to my system, which is my local folder. So copy as a path. So I'll paste here. I need to get a different file than this. So I want to take modeling 4 here. This is a file I know, which I have to import here. All right. So this I'll run the code again, shift and enter. So now you will see this code is successful. So we are able to successfully import. So import the, so let me see the shape of this file. So if you look at, there are 344 rows and 15 columns are there. Then also I'll see the data. So data top 5 rows. There are top 5 rows. So what I need is I need auto sale underscore trend. This is where I will be applying my weighted moving average and exponential moving average. So I will take D is I'll give a name data auto sale underscore trend. I'll run this. So after running this, so this is successfully run. So we are able to define our data frame. Then I'll define my weights. So weights, just now we have discussed the weights. So I'll give zero point 0.2, comma zero point 0.3, comma zero point 0.5. These are the weights. So now I have my data for which we have to on which I have to apply weighted moving average. Also now I have the weights. Now I have to define the formula here, define the function here. So the function is weighted moving average data and weights. Okay, these are function which I am defining. So w underscore m underscore a is equal to data dot rolling. Okay, window means what is the moving average period. Window is equal to length of the weights. So we have three values in the weights. So we'll directly give the length of the weights. So by length of means how many weights we have. Whether you have 3 weights or 4 weights or 5 weights. If you have 3 weights, then we'll do the moving average for three periods. And then apply the function, the expression here. Dot apply lambda dot x lambda dot x. The expression is np dot right, and this is x comma, weights. So let's in return W and yes. So we are seeing some error over here. So let's see what is the error. So we're seeing some invalid syntax here. Data dot rolling window is equal to length of weights. There's no problem here. Apply lambda. Right. So it is corrected now. So now we are going to apply. Actually, I gave here the dot, so this dot is not required. Now let's go into the let's calculate now. So I'll be calculating WMA is equal to weighted underscore moving underscore average. In this particular program, we have data in the form of D. We have weightages in the form of W. So if you look at the formula data underscore weights, what is data here? That is D. What is weight here? W. Right? So I then so this is my WMA. And I do the plots now. So D dot plot WMA dot plot. So this is my blue line is the sales and orange line is the forecast. Right. So I think if you look at the graph, you're getting a very good forecast. Getting a very good forecast. We are getting a very almost close to mapping. Now what I'll do is if you look at here, this there is some NaN values are here. So we'll try to drop these NaN values. So I'll go and write WMA dot let's go let's do the WMA dot drop NaN. Right. So I have dropped some those values. Now I'll find the error. Let's see whether the error is working or not. So first we have to find mean underscore absolute underscore percentage underscore error. And we have a D and we have our WMA underscore 1. So we are getting some error here now. Let's see what is error. Found input variable with inconsistent numbers 344, 339. There are some values which we are not able to capture. Okay, so we'll drop here. So now we will go and do the same thing. And I'm going to copy this data, copy this. I'll go to a new file, new coding window. I'll paste here, same thing. And I'll go and bring the same data file. Just copy this. and paste over here, right? And then what we will do is that we are going to take the same data. I'll go and copy and paste over here because now we're building a new algorithm and the same weightage. No, the weightage will be changing now. So the weightage will be 1 equal to 1, 2 divided by, I'm taking 12 periods, moving 12 periods, moving average. So 1 minus 2 by 30. These are the weightages. I'll run the code. So there is no problem here. I could, yes. Now again, I'll define, in this time I'll define exponential moving average. Exponential moving average data, comma, weights. So we'll write EMA is equal to data dot rolling. Okay, so window length of the weights. Again, we'll apply lambda x. This time we will use x into weights. You dot sum return e underscore m underscore a. We have some problem here again. Let's see what is the problem. In value syntax. So data dot rolling window length of weights. Okay, length of weights, no problem there. Dot apply, no problem there. Lambda x. Do we require a bracket here? So definition, exponential moving average is fine, no problem here. Exponential moving average data and weights. So E underscore M underscore A is the data dot rolling. Window is length of weights. Right. Apply lambda. So lambda x. Okay, so this should be not double dot, this should be equally. So now it's running. So we instead of double colon, we have to put this equal to sign. Now I'll run if it's exponential moving average, EMA is equal to. So what is the formula? That's the formula is EXP underscore MOV the underscore D comma W. Right. So I'll run the code. Case was working. EMA. So we're working. And I'll build a plot between EMA. So D dot plot EMA dot plot. So this is the exponential moving forecast, and this looks even better than the weighted moving average. Right, guys? So this is how we are building our two important forecasts modeling, weighted moving average and exponential moving average. So now this is a one-time exercise because every time I have to change my data model, right? I have to change my data model. So that I don't have to change, if I have to change, in the case of exponential moving average, we don't need to change the weightages. But in the case of our weighted moving average, I can change these weightages. But only thing I have to make sure that the sum of the weightages, the sum of the weightages has to be equal to 1, right? The sum of the weightages np dot sum w. So the sum of the weightages has to be equal to 1. That is a condition we have. So you can make it zero point 0.3, you can make it zero point 0.2 here, then zero point 0.5. You can make it 0.7, 0.7, 0.2, 0.1. But what we have to ensure that the sum of the weightages has to be equal to 1. That's a check we have, np dot sum w. So this is how we are doing our two important models, and it's very simple. So now you don't have to run the code again and again. Just you have to change your data model. Once you change your data model, you have to just run the code and you will get your output. Right? So in Python, once again, I'll tell you that most important is that you need to know which packages, which libraries you need to import inside your Python to run the code. That's the most important thing. And then once you have that code ready, you just have to change your file. Once you change your file or the data, rest everything is it's a cakewalk. So if you want to learn the total demand forecasting, okay, so you need to contact me at krishnaidu@mathmail.com, or you can also WhatsApp me +918977924627. Please feel free to contact me. I'm there to support you. I'm there to help you to build your career, to achieve your career objectives, to career your ambitions. I'm there to help you out throughout, right? And we also provide video recordings, session recordings. We try to put our batches in a very comfortable time for the people with their consultations. So please talk to us, and we will be helping you in actually providing you a badge which is very comfortable as per your work and personal life, so that you can completely focus on this training. And if in case if you miss any sessions, we are also providing you the video recordings, session recordings. You can go through those session recordings and you can get your hands on. Okay, guys, so I'll take a leave and I'll come with the new recordings very soon, and then we'll discuss on them. Thank you very much.